ladies and gentlemen, colleagues from the faculty, and students, thank you for coming here to listen to this talk. The topic is the end of the Bronze Age civilization of Pakistan and India, which we call the Harappa Civilization, 2600 to 1800 BC. Archaeologists speak of civilization when they find a sizable geographic spread of similar assemblages at excavated sites. These assemblages comprise pottery, stone tools, metal weapons, metal tools, and other things which have a functional connection. Certain metal tools, for example, were used for making certain ornaments. Those ornaments we may find depicted on images of people, and they then relate to the symbolic sphere, and so on. There is also, I fear, a value judgment when we speak of civilization. Civilization is that stage when the rude mud hut gives way to the two-story brick house, when animal skins give way to embroidered fabric in the clothing at least of the ruling elite. This statue, Harappan statue, though only 7 meters high in what remains, is obviously carved by a master of steatite carving. It has a formality, a monumentality about it. This really miniature bronze casting of a buffalo, exquisite in detail, mass, and what it wants to convey of a huge and clumsy creature in a miniature, I think is quite exceptional for the Bronze Age. And then we also have a rather elaborate technology that went into the making of opulent jewelry such as this. Civilizations are geographically extensive. The Harappan settled area is marked by the polygon on the top left hand of this map. It was twice the area of the contemporary civilization of Mesopotamia. Harappan civilization settlements lie in South Punjab, Sindh, Baluchistan. If you can place them, Baluchistan, the Kirthars here, Punjab, Sindh, a lot of settlements in Kutch. Please don't forget them, because the scientists who I am going to rip apart have dismissed Kutch in half a sentence. And then there is the divide here, which we will speak about later. There are fewer sites in Saurashtra, and there are outlier sites like Surkagandor in Makran, where today the Chinese have set up that horrible port and are handling all the trade. I don't know what is left of this settlement. And up here in northeastern Afghanistan, in Badakhshan, is the lapis lazuli procurement station of the Harappans. Between the two large cities, Harappa and Mohenjo-daro, I wish to kind of just alert you to, Harappa is here, Mohenjo-daro is here, is 600 kilometers. This is a very widespread civilization. How was such a large area characterized by basically the same material culture? Of course, there were regional variations notwithstanding. Was it trade that united the region? After all, about 30 sites have produced cubical chert weights of this sort, which conform to a particular range of values. These may have been used in the business of trade, but we can hardly say that these rough lumps, called terracotta cakes in the jargon, could have been traded. They were probably part of the pyrotechnology of fuel makers or those who set up kilns for metallurgy, but they could not have been traded. Neither do I think would pottery have been traded all the way between Sindh and Badakhshan, that northeastern site that we saw. Was the connecting factor then ideology? We are all aware of these fascinating ladies. Were there cults of the mother goddess or some other female being? I have to point out that this kind of terracotta woman, sometimes frightening, sometimes weird and maybe a caricature, not only are they varied, but they seem to be confined to Harappa and Mohenjo-daro. There aren't others. There are no such figurines in the Kutch sites, in Kalibangan, in Rajasthan or Haryana. And if we look at these copper tablets, they seem to be like the tavis. On one side of each is a sacral creature, a kind of mystical animal, and especially if you look at the middle one, and on the other side is a spell or the name of a person or personage or spirit inscribed. Here is the mystic hunter. He's also shown on these. And the important thing is that this kind of artifact occurs only at Mohenjo-daro, nowhere else, and that too in just one period. So then if we say it cannot be an ideology that united the whole area, we move to consider urban centers. This is a view of Mohenjo-daro from the air. There are public buildings on the citadel. I think many of you will recognize the bath. On one side of the bath is the so-called College of Priests. On this side is the granary, the storehouse, perhaps of grain, perhaps of other things. Most potent for me is the least glamorous of these pictures, which is a picture like this, to show you the dense housing of the ordinary people of Mohenjo-daro. A city such as this, with public and residential structures, craft production, a dense crowding of the habitations, and of course the famous drains, which all school children learn about as civic infrastructure, could not have been inhabited by n number of kin groups. The population was at least 12,000, if not more. City residents could not all have been descendants of one ancestor. Instead, a set of functionally integrated institutions emerged in the city with the transformation of egalitarian society into a stratified society. In other words, there can be no urban life without a state, without a ruling elite that commands, that organizes, that coordinates. And we have seen in MA class, we have read a tract by Salins which said, it is the state that differentiates civilization from tribal society. City people have dealings with many other residents to whom they are not related. These dealings are particular purpose dealings, momentary transactions, and they are facilitated by this kind of artifact, the seal. To stamp and seal packages of goods, to authenticate messages that may have been verbally or sent in writing, and to convey both verbally and visually a person's identity, very much like the identity card or the passport. The stamp of a state society and urban life is evident not only in these seals, you can see that they have been written on, and there is also the sacral emblem on them, but also in a host of other written materials such as this. In state life, in urban life, you need to record complex transactions, quantities, names of givers, names of receivers, etc. Because the state had ushered in what we call a supra-household system of production and distribution. Incidentally, 90% of all Harappan inscribed objects come from just two places, Mohenjo-daro and Harappa. Meanwhile, and we don't have very good photos of it, the most stunning writing of all is at the Kutch iconic site of Dholavira. 10 signs cut out of stone, huge signs, almost 40 centimeters tall, stood up at the north gate of the citadel of Dholavira. Obviously a public message. What it was, we don't know. Associated with writing was the standardization of the kind of weights that I had showed you, and a lot of use of bricks. I think this is a good illustration of the fact that bricks were of uniform size and dimension. In school we were told that this means that the Harappan people were so disciplined. I don't think this is the case. It is a question of absolutely masses of bricks having been to produce by the lakh. You have to get the mud shaped, you have to get the mud bricks to be turned over in the sun to dry, then to stack them in a way, to then organize the fuel, to bake them to a certain size, cool them down, then have them transported to the building site. Strangely, something like this is also a product of mass production. Stone blades by the hundreds occur at Mohenjo-daro. They occur by the dozen, even in arid places like Makran and Kutch. Wherever there were local Stone Age communities, they lost their old stone tool flaking traditions, and they began to make these long chert blades. The material is chert from Rory. They were set in bone and wood, and we owe it to the understanding of F.R. Olchin, who said these were once set in wood or stone, these were harvesting tools. And it is he who said, this is what tells me that across the Harappan realm, the populace was set to work on the harvest of the agricultural fields. What occurred at the end of the Harappa period was not that the population, like the dinosaur, disappeared, but that very gradually people migrated. City life was not viable anymore. With city life also went writing, the crafts, the baked brick architecture and brick wells, also the bronze tool forms and chert blades such as these no longer were made. The exception is the knowledge of the staple crops, the rabi crops, wheat, barley, lentils, peas, chickpeas. These had been grown by individual families for generations, and this agriculture subsistence economy continued. So did the animal breeds. That is to say, it was forms of material culture associated with the state that lapsed, not ways of life that a family could control and continue on its own. In June 2012, newspapers from the Los Angeles Times to the Hindu announced that scientists had discovered why the Harappa civilization came to an end. The Indian Express headline flashed, "Did rains do the Harappans in?" And this is what I have plagiarized as the title of this talk. These newspaper reports had followed the publication of a research paper in the Proceedings of the National Academy of Sciences, USA, the title of that paper being "Fluvial Landscapes of the Harappa civilization. Fluvial for my students, meaning of the river, flowing, river regime changes, and so on. This is again, I think, interesting, perhaps amusing if scientists would later like to comment on it. The authors are 15 in number. The lead author is a geoscientist, L. Giosan. The study was located on the plains of the Indus, on the Indus plains coming right down here, and also in the region that I will now call the divide between the Satluj River here and the Jamna River here, mainly here. In this divide, and this is a map made by my Professor V.N. Mishra of Deccan College. Again, you see the Satluj here, and numerous rivers, if you can detect their names, the Chautang, the Drushadvati, the Ghaggar, and so on, flowing southwest, flowing to join the Ghaggar, and then continuing in Pakistan as the Hakra, perhaps the same river or a continuation of that channel, then named the Eastern Nara, flowing south and entering the Great Run of Kutch here. This map Professor Mishra made using two old maps by the Oldham brothers, and this 1984 paper of Professor Mishra, I think, still remains a classic. It's a very great shame that these scientists don't even cite the paper. The mineral contents of sediments of various ages from the various riverbank sections were identified by the scientists, and they were dated. And they were thus matched with the rocks of the Greater Himalaya. You do a matching, you can do a matching because each of these ranges, not only do they have different heights and elevations as you see here, but each has a different age. The lesser Himalaya or Shivaliks are 1,500 to 2,300 million years old, but the greater Himalaya are 750 to 1,250 million years old. This matching led to the conclusion that while the Indus and its tributaries, back to the old map, originate in the highest Himalayan slopes, that is to say in glaciers, it snows in the high Himalayas in winter, the sands and sediments of the Ghaggar Hakra bear the imprint only of the lower ranges where snowfall is rare, and so they were fed only by rainfall. This is one of their first findings. Now, climate change has been written about by archaeologists for decades. It is repeatedly said that rain and snowfall emanating from the Mediterranean and falling over Western Asia saw a marked decrease between 2200 and 2000 BC. This is so entrenched in the literature, you have to be very brave to doubt it. But what about the monsoon? This paper cites work on stalagmites in coastal Oman, on cores taken in the bed of the Arabian Sea in Central Asia, to say that the monsoons also diminished. Neither in this paper or in an earlier paper published by Madella and one of the archaeology authors of this paper, Dorian Fuller, in 2006, even there it is not categorically stated that the decline in monsoon rainfall took a sharp turn downward in 2200 and not 200 years earlier or 200 years later. The paper notes that the Harappan settled zone, being everywhere a rainfall deficit zone for agriculture, and canal irrigation being impossible for the rabi crop, the wheat, barley, etc. I had mentioned, because all these rivers are at their lowest in the wheat growing season. Third, that the plains of the greater Indus Valley rely on summer floods to give a pre-sowing irrigation before the planting of wheat and barley in October, November. A major reduction in rainfall would have lessened the magnitude and regularity of floods. This is basically the thesis. The rivers of the divide, they say, these rivers, being only rain-fed on the Shivaliks, from the Shivaliks, were the ones to begin to dry or recede and become seasonal. So many settlements on the densely settled Hakra, for example, here, were found, and that were founded in the Harappan period, were deserted and people moved upstream. There was de-urbanization. Drought-resistant millets were introduced in the late Harappan or the post-urban period. Today the Ghaggar, Hakra, Eastern Nara channels are dry or seasonal. I tried to show with dashed lines where they are particularly seasonal and unreliable. Only in upstream Haryana are they perennial rivers flowing with some certitude. But this now dry channel is a long one. It's a very wide one, 2 to 4 kilometers wide in places. The old thinking had been, even if a 30% higher rainfall than today's had occurred or declined, it cannot account for such a wide and long river. So it was something other than rainfall that made this such a, and everyone, I myself am guilty, have written that it was a mighty river. We start with this adjective used by Professor Mishra. So, tributaries that today feed the Jamna could in Harappan times, so we were taught, I was taught in MA, have fed the Chautang Saraswati to give them such a great flow. How did that happen? They could have been flowing near the Jamna. This is a kind of, this other scientists have just picked up their map and diagram to show you how closely knit are the Markanda, Saraswati, Som and other tributaries flowing either into the Ghaggar or in the Jamna. After earthquake, it is very possible that the Jamna could have captured certain streams that were before that feeding the Ghaggar and Hakra and going southwest, so that now the water was going east and southeast. But the finding of this scientific paper that I am discussing says this is not possible because there is no Jamna material in the sediments of the Ghaggar Hakra. The scientists used clusters of zirconium silicate crystals, dated them by optical stimulated luminescence to understand their dates, the date of when these crystals were last exposed to sunlight. Really an extremely sophisticated technology. However, back to Professor Mishra, the geoscientists did not refer to his paper, to other older literature, and they make only passing reference to possible flows from the Satluj. In his map, Mishra shows that the Naivals, for example, there are at least Western Naival, Naival, Eastern Naival, perhaps the Va also. According to Mishra, they all emanated from this east to west stretch of the Satluj when the Satluj was in flood. H.T. Lambrick, the geographer of Sindh, and Muhammad Rafiq Mughal, the most eminent of the Harappan archaeologists of Pakistan, tell us that there were overspills of the Satluj also into the Hakra, this densely occupied Harappan area near Fort Abbas, and one short channel again from the Satluj near Yazman into the same river. In that case, what we are finding is that there would have been some flow in the divide that came from glaciers in the high Himalaya via the Sutlej. The Sutlej incidentally has a huge and intricate catchment in the greater Himalaya, and a scientific paper of 2010, which these authors cite in their bibliography, it estimates that snow melt contributed about 57% of the flow of the Sutlej. So there is something a little dubious about this thesis. There are other difficulties also. If the period of lower rainfall is found to be 2200 to 2000 BC, the one carbon-14 date for post-urban Harappa on the citadel is 1730 BC. Is that all right? Is this a fit? Is this a not a fit? Is the discrepancy? It is not discussed. In Cholistan, this is the Gaggar in spate in the monsoon, in Haryana. Rafiq Mughal's map of the 83 dense Harappan settlements shows that when they were replaced by later Harappan settlements, late Harappan post-urban, which I marked with a cross, the area was still roughly the same. I quote him, "The post-Harappan settlements concentrated in the very same area where mature Harappan sites were located." So the move upstream occurred only in the Iron Age after about 1000 BC. In the mountain catchment areas of the rivers, there occurs both summer monsoon rainfall and winter rain or snowfall. Winds from the west blow over Turkey, Iran, Afghanistan and bring snow and rain to the Himalaya. Snow is stored on the higher slopes until about April, when it begins to melt and begins to flow towards the plains. Recent work, I repeat, has concluded that more than 50% of the discharge of both the Indus and the Sutlej comes from winter snowmelt. Is there any connection between the winter streams and the monsoon? Giosan and his colleagues do not discuss this, but according to one paper, 2010, they are two independent climatic regimes. Hydrologist Robert Rakes, who had worked at Mohenjo-daro and Kalibangan, had written, this literature is too early for these poor youngsters to quote, "A strong southwest monsoon can block the westerlies. Westerlies may gather strength when the monsoon weakens." Rakes wrote, "Either there was less snow or less monsoon, not both. In that case, we cannot generalize about lessened flow in the rivers." More important, of course, is the causation chain. How critical for agriculture would a lower magnitude of flood have been? I think this is the most beautiful photo of the Indus from the air that is available on the internet. The Indus, with its huge catchment and annual floods in the past, flowed over an enormous accumulation of alluvium that it deposited annually once the velocity of floods declined. Its alluvium lies on a massive unconfined aquifer, a transmissive aquifer moving laterally and up and down all the way into eastern Sindh, into the divide, and from the Indus in the west. This was a great store of water that the Indus was flowing over. In the traditional system of agriculture, for wheat and barley, whenever floods had not moistened a patch of ground sufficiently, the peasants put in kacha wells to provide additional water for irrigation. Mohenjo-daro has been called the city of wells. It lies, even though it lies only 4 kilometers from the Indus. Also, although Mohenjo-daro had the lowest rainfall of the Indus Valley and the greatest rainfall variability, it has the most productive agriculture. It is because of the water resources on the ground and below the ground. The 19th century travelers' accounts that I looked at, the report of the Indian Irrigation Commission of 1901-1903, and a land use survey of the entire valley by I.C. Fraser in 1958, all emphasize the importance of well irrigation for rabi crops. This in spite of pre-colonial and colonial canals, inundation canals dug across the plains. Take the Montgomery district, where Harappa is located. It was named Montgomery district after engineer Montgomery, who built the canal system of that area. The gazetteer of the district says, once the wheat has started growing, farmers move to their wells with their cattle and the fodder for the cattle to work at lift irrigation for the entire growing season, each well having become a little village. Significantly for Bahawalpur state also, which was our Harappan heartland in the divide, one engineer testifies to the Irrigation Commission, I quote him, "No man likes to put in rabi without a well. It is the sine qua non of wheat agriculture." And the commission records that it received 11 lakh applications for digging wells in that area, Bahawalpur area, in about 2 or 3 years. I had mentioned the 20 or 30 Harappan sites in Kutch, spread from the west of the peninsula. They spread from somewhere here near this K all the way towards the here and then here. There are 20 to 30 here. Now this scientific paper dismisses Kutch, saying it was never dependent on flood agriculture. True, there are no large rivers to flood, but agriculture? Of course there was agriculture. All the Harappan crops have been identified and attested at the site of Dholavira. This is our iconic site in India. The scientists say Kutch being a coastal region, but the sites are not on the coast, relied on trade. They also wrongly say that in Kutch, the Harappan tradition endured beyond 1800 BC, so it did not come to an end, which I think can be contested. The Kutch Peninsula has no winter rain, no perennial river, very poor monsoons with great variability. Khadir Island, on which Dholavira stands, gets an average of 262 millimeters a year, but this rainfall can come in only 9 days of the year. So obviously it is important to look at monsoon management at Dholavira. It is a 40-hectare site, the 3rd or 4th largest Harappan site. Khadir Bait is an inverted triangle of fractured, permeable sandstones and limestones. Rainfall can sink to a depth of even 18 meters below the ground at some places. The northern edge is sharp, a 120-meter high ridge from where dozens of rivulets flow southwest and south, and 2 of these hit the site of Dholavira. They are seasonal streams. They may hit as and when it rains. Here is R.S. Bisht's plan of Dholavira. There is the 40-hectare settlement enclosed by a town wall, except here the wall was damaged. Here is a high citadel a lower attached area which Bisht called the Bailey. There is an open processional way here, a middle town, a lower town. All the drains slope this way towards the west of the settlement, and this series of reservoirs is not on scale at all. This whole series of reservoirs would fit in here, but I have enlarged them to show you how intricate is the layout of them. I have of course taken them from Bisht's plan, and he also found one large east reservoir here under the citadel, which he called the Eastern Reservoir. So ladies and gentlemen, what I am trying to argue for is that in Kutch there was a system for harvesting flash floods to store under the ground. A check dam on the Manhar has been here, somewhere here. Bisht found the remains of it. I inspected that area. I could not make head or tail of it. I don't have the expertise to do that. But the Eastern Reservoir is a huge one. Sorry, before I do that, I just want to show you the citadel storm drain. More than 5 feet tall, made of semi-dressed stone. You can imagine the kind of storm water that the people were prepared to send down the citadel into the western area. Here is the partly excavated Eastern Reservoir. You see steps going down here. There were steps on this side as well, this side as well. The reservoir is 74 by 26 meters, more than 7 meters deep. It would have been the first tank to receive the flood. With the flood water would have come branches, mud, dirt, stones, everything that flowed in with a high velocity. Not just this flight of stone steps, then all the others show that there was ample provision for people to descend to the floor of the tank. Why? Obviously to clean out the rubbish brought in by the floods. To clean and clean, even if there had not been floods, to clean again, repeatedly. Very interestingly, and not exposed to the tourist who comes to visit this site and only wants to know where is Pakistan. Some obsession when you get to Dholavira of finding out where Pakistan is. But here, they are not allowed, they are not even told that it exists, is a 9-step well into the floor of this reservoir. So a connection is being made not only between storage of water under the then walking service, but even in a stratum below that. I think the southern series of drains is also important. This is one, this is SR3 as we fondly call it. There are 3 stages down, beautifully accurately cut steps. It is on the south side of the citadel, and this picture will show you how tanks connected one with the other. This is the shallowest and smallest of them. There is a ramp and no steps, and this is a rock cut one. And then from here, channels start to lead water to the west of the settlement. The vertical dimension, I think, was the most important. The lowest level in that tank that I just showed you actually had rainwater in it in November of 2010, which made me think at that stage, or perhaps later, that if modern archaeologists had scraped and preserved this floor, maybe this water also would have filtered down into the aquifer. I show you 2 problems of this kind of water storage. All right, to store water in these huge tanks. First of all, algae would have appeared in the water, which was exposed to the sunlight. Unless we introduced frogs or fish or chopped barley straw. Apparently that keeps algae from forming, because otherwise I found my hypothesis was not accepted by people. They said, what would you have done about algae? There are home remedies to stop the walls from getting green and slimy and to stop the water from getting poisoned. But the main problem would have been evaporation. How would you keep water from one monsoon to the next? A lot of it would have evaporated. So I suggest that the flash flood water, once received, the floors once cleaned, could have been sent underground, perhaps to recharge the water column of what is the largest Harappan well that we know. This well is 4.2 meters in diameter. They dug 13.6 meters down and didn't find the water. It is probably a very, very deep well. I've been going back and forth to Dholavira every time with a new set of problems in my mind, not knowing how to solve them. But very often it has come to my mind, was this a disproportionate investment for a population that may have not been more than 4,000 or 5,000? No, because sea levels being 2 meters higher than they are today, Khadir Bait would have been surrounded by the sea 12 months in the year. So this was a system for making provision for water for maybe 2 years ahead, 3 years ahead. We don't know when the rains will fail in Kutch. This project would have meant deploying and managing community labor to cut stones, to make plaster or mortar, to repair embankments, and to clean, and clean again. Today, water under my land is mine to do as I please. Between 1985 and 1995, wrote Lailat Bavadam in Frontline, the water table in some parts of Kutch fell by 10 meters in just 10 years. In Pakistan, they face the opposite problem. The British greed for agricultural revenues and a lavish system of run-of-river inundation canals, unlined canals which were given no drainage, has meant that an extensive waterlogging took place. And what is this? Indu Agnihotri has written about this. Engineer Fatehullah Khan has a blog which writes about this. But Syed Ali Naqvi wrote in a big tome in 2013 that no one in Pakistan understood the cause-effect connection until after 1950. That in fact the canal system was bringing ruin to Pakistan. Whatever it may be, the geoscientists who are trying to find the cause of the end of the Indus civilization are not interested in subsoil water. Their discussion remained about rivers and river flows. Their paper taps a range of state-of-the-art scientific procedures. Data from the shuttle radar topography mission was used for a base map. They used the accelerator mass spectrometry radiocarbon technology to date river sediments. With optically stimulated luminescence dating, they examined zirconium silicate grains. I had to look up all this in an encyclopedia. I didn't know it. And studies of Arabian seabed cores gave them dates of variations in the discharge of the Indus. I cannot claim even a basic competence with such techniques. So the first reaction becomes to accept, because scientists have said this. You are intimidated, you are awed. They have said this. So there is a connection to the decline. Then one begins to think, what about social science? What about the geography of the Sutlej? What about the source, the snow source of the Sutlej water, the snow-fed side? What about doing some basic reference work of papers that were written 20 years, 30 years earlier. And social scientists would always look into traditional agricultural practices. When they wrote about something like agricultural decline, there is not a word on that in this report. At the outset, I had mentioned the early state that gave coherence to the entire Harappan map. After 1800, it was BC, it was street drains, the weights, the writing, and this kind of Dholavira's impressive water harvesting techniques and systems that were eclipsed, not ordinary householders' technologies. Did a geographically extended state, extended perhaps because of the expansion of its frontiers being built into the politico-military system, carry the seeds of movements towards local autonomy and retribalization? So was there an inbuilt, some kind of contradiction? There is another question. If subsoil water was valuable, still it always has to be lifted out. Doesn't this make agriculture rather labor intensive? Did it lower the agricultural output per unit labor? There are many such questions. 20 years after Salins made his statement about civilization and the state, J.A. Tainter wrote a book on the collapse of complex societies, comparing societies across the world which declined. And he said, civilizational collapse is tantamount to the ends of a state. Perhaps then, we can accept environmental change as one aspect, but we should be turning our attention elsewhere also. As my friend and role model Uma Chakravarti remarked once, political power is not something that ever lasts. Thank you so much for listening.